following has been developed by state and provincial agencies in association with the Agency for Instructional Technology. Together, serving education.
Space. A shaft of light shining through space. Not outer space, a school auditorium. The light's coming from that doorway.
Well, Sam, you're the first to arrive. The bus for camp isn't due for a while.
Thanks, Mr. Ritter. I thought I'd get here early. I've got a little repacking to do.
If this were outer space, and Sam were docking at a space station, he'd have smashed his wings off by now. Astronauts have to imagine ahead so they can predict how shapes will fit together. They need to know how the appearance of an object changes as they move or as the object moves, and why the object looks different. The rest of us use these skills too. Just watch.
Thanks, Mr. Ritter. I'll repack up here on the light.
That ability to see ahead as shapes move or as you move is a key to understanding spatial relationships. It's also a key to getting through life without bumping into things. We are all pilots of our own bodies, and we have to adjust as we steer them through different spaces or as things come at us. As we grow, we learn to maneuver and experiment. We observe movements and objects, imagine what will fit or what won't fit. Make judgments and test them. Judging shapes and space is useful for everything, from brushing your teeth to parking a car. Meanwhile, let's see how Sam's doing with the same kind of problem.
Okay, gotta hurry. Can't try 'em every which way. Have to try and predict, in my imagination, whether the end of this rectangular container will fit that space. Won't go there. Wait. Bingo! I try it out in my head, try turning it, and seeing different angles, and it works. Now what about this triangular container? My guess is that this point will fit there. No. How about this way? Yup. I think it will. I think it fits. All I had to do was try and imagine new combos and say to myself, I bet this object will fit next to that object if I turn it. So, now my bag won't be quite so stuffed. Maybe I can fit some of these shirts soon. I was worried I'd have to wear 5 layers of clothes because I couldn't fit them in my bag. What the? Yikes!
Once upon a time, our galaxy was terrorized by a gaggle of geometrical gangsters going from planet to planet, robbing all the banks right, left, and center. One night, this swarm of shadowy shapes invaded the sleepy town of Beamsville and broke into the local bank.
Stop dreaming, Peabody. Let's get on with it. This is obviously the work of a small circle, a large circle, and a medium-sized square. The shape invaders.
But, Sarge, shouldn't we see if there are any witnesses?
Oh, very well.
There had, in fact, been 2 witnesses. The old couple who lived across the street, Mr. and Mrs. Spratt.
I was down at street level. and I could swear that I saw a long, thin rectangle and 2 triangles sneaking into the bank.
So, there were 6 of them.
But we haven't heard the testimony of Mrs. Spratt yet.
Oh, very well.
I happened to glance out of my top floor window, so I had a bird's eye view of the burglars. And I could swear that I saw a small circle, a circle with a dot in the middle, and a square with a cross on it, sneaking into the bank.
Ah, the small circle. That matches the shape print, so we can forget that. But 2 new shapes. A circle with a dot and a square with a cross. 8 shape invaders altogether. This is definitely a case for the shape squad.
But wait a minute, Sarge.
What is it now, Peabody?
There are only 3 of them, really.
How do you figure that?
These 2 shapes are really only one shape seen from 2 different angles, and the same applies to these 3, and these 3.
Have you been dreaming again?
In a way, yes. I've been using my imagination to make some mental pictures.
What?
Well, I tried to imagine what would leave the print of a small circle and yet look like a long, thin rectangle from the side. A cylinder. Then, I tried to picture what would leave the print of a large circle and look like a triangle from the side and a circle with a dot in the middle from above. A cone. And finally, I tried to think of what could leave the print of a square but looked like a triangle from the side and a square with a cross in it from above. A pyramid.
Now that the Beamsville police force had a precise description of the shape invaders, it wasn't long before they were able to track down Cylinder Sam, Conehead Malone, and Pyramid Pete, and thus put an end to the dastardly intergalactic crime wave, thanks to the vivid imagination of Officer Peabody.
Hey, Sammy, did I scare you? Or did I scare you? Ed, sorry about your stuff. Let me help you. I see you're still hooked on nuts. Yeah, I got 8 different kinds here. Where'd you get those masks? Oh, my attic. Saved from Halloween. Did you see how these things fell? I like that. Maybe we can work that into our act. What act? Our act at the camp show. We gotta start rehearsing.
Oh, no, Ed.
Oh, yeah.
They hooted us off the stage last year.
They hooted you off the stage last year. Me, they simply threw off the stage. You mind if I try that again? You know, they really do seem to change shape as they spin and fall and bounce around.
Yeah, things look different from different angles.
Why do these shapes look different as they move, or you move? Because you can't see all parts of the 3-dimensional object at the same time. Knowing how things look from different angles is especially important for Aaron Curzon. He makes holograms. And what are holograms? Well, here's one. Your future is going to be full of them. This hologram is part of the metal sculpture you're seeing, also made by Mr. Curzon. He was his own model. Thousands of images of his face have been put with a laser on this cylinder, recording how he looked from every angle. Those images are what you see when you move around the hologram.
I'm the artist, painter, and a sculptor, and I made this. It's a hologram, a 3-dimensional image in light made with a laser beam. This is a special kind of hologram, though, because not only does it show all the different views of the object, which is characteristic of all holograms, but it also shows the movement of the object, which you can see as the expression changes on the head. Here we have a ruby laser setup, which is used to produce a holographic image. If we were going to make a hologram of this clothespin right now using this setup, we would be getting all the image information of the clothespin at an angle about like that, right onto this very plate, would have all that information. And that's basically how a hologram is made. It's very important for a holographer to know and to be very aware of the changing shape from different views of the object, so that when he the image that he creates will do compositionally and artistically and expressively exactly what he wants.
Shapes look different from different angles because you can't see all sides at once. This is a cylinder, but if I only show you this side, you see a circle. Or if I turn it this way, you see a rectangle. This is a pyramid, but if I only show you the base, what you see is a square. Or if I show you one single side, you see a triangle. To notice the differences, do a little dance with the shapes in your mind, the way a holographer would, or the way Officer Peabody did to catch the shape invaders. Back in the auditorium, Ed has a kind of shape dance on his mind, but Sam's not getting the picture.
Juggling these shapes really paid off for you. You got room to spare in your bag. Hey, a Casio. All right. I feel a song coming on. We can use it in the show.
Ed, come on.
Come on yourself. We can do a music video. They'll love it at camp. Hit it. Well, give me a rhythm section at least. Come on, come on. Slow boat. Come on, you can play this thing. Let's go, let's go. That's good, that's good.
Oh, you shapes. Oh, how you seem to change now. As I move around you. And you seem to keep on changing. When you start yourself a moving too. Oh, I really want to know right now. Shapes. Should I call you by some brand new name? Shapes. Have you gone and changed on me? Shapes. Or have you truly stayed the same? Shapes. And those shapes talk back to me and they say, well now, Ed, we haven't really changed now. As we move, and you move too, we just look a little different. Your new angle makes us seem kinda new. Ow! But we really want to say right now, Ed, please don't call us by some brand new name. No. We may turn, we may fit together, fit. But our shapes will really be the same. Shapes. Oh, how you seem to change now. Shapes.
Movement makes an object change its appearance. The more carefully you notice those changes, the more developed your imagination is going to be. It'll help you predict how shapes can move, turn, and fit together. It is a little like a dance, or a space voyage, one you best appreciate with your mind's eye.
Shapes. MathWorks is a component of the Mathematics for the 80s project and is supported in part by Exxon Education Foundation. This program is produced by Peter Barton, under the supervision of the Agency for Instructional Technology.